We are going on with revision for paper 1, and our focus now turns into inequalities. And we are going to deal with the following examples. They increase in difficulty as we go along, and it's important to go through all of the different variations in order to be successful in the examinations. In our first example, we have 3x minus 2 in brackets squared is bigger than 3x. And what we want to do is rewrite this in standard form. So let us multiply out first. So 3x minus 2 squared will become 9x squared minus 12x plus 4, which is bigger than 3x. So remember that a bracket squared is simply two brackets that we need to multiply with each other. So it's 3x times 3x, 3x times negative 2, negative 2 times 3x, and negative 2 times negative 2. That's how we get the left-hand side. Now I'll rewrite this in standard form. So it'll be 9x squared minus 15x plus 4. Now, in order for me to continue, I need to factorize or use the quadratic equation to find the critical points. So I would factorize. So it'll become 3x and 3x and 4 and 1. And if I test it, it'll be negative 3x minus 12x, and that will give me the middle term. So I know my factorization is correct. Therefore, I have two critical points. These are simply values of x which will satisfy the equation if it was to be equal to 0. So x is a third and x is equal to 4 over 3. Now I can represent those critical points on a number line. So the smaller value would be on the left and the larger value on the right. So a third is on the left and 4 over 3 is on the right. And I want to determine where the graph is bigger than 0. So anything above the number line would be considered bigger than 0 or positive. And anything below the number line would be considered smaller than 0 or negative. And I can also see that this is a quadratic equation and the a value is positive, so it shows me it's a smiley graph. And if I draw in a smiley graph through those critical points, I can see everything to the left of a third is bigger than 0, and everything to the right of 4 over 3 is bigger than 0. And everything in between is negative or smaller than 0. And because we're looking for values bigger than 0, I can see that x must be smaller than a third, or from a third I need to move more to the left, and x must be bigger than 4 over 3, or to the right, all the values to the right. And you can see the inequality almost works like an arrow that points to the left and to the right. In our next example, we have x minus 3, x plus 2 in brackets, bigger or equal to negative 4. And we want to follow the same procedure as before by multiplying out and rewriting it in standard form. So it will be x squared minus 3x plus 2x minus 6 is bigger or equal to negative 4. And I rewrite that in standard form. So it will be x squared minus x minus 2 bigger or equal to 0. Because I move the negative 4 to the left, it becomes positive. So it's minus x plus 4, and that gives me negative 2. Now I can factorize. It'll be x minus 2 and x plus 1. Therefore, my critical points would be x is equal to 2 or x is equals to negative 1. Now let's represent them on the number line. Remember, the smaller value goes on the left, so negative 1 is on the left and positive 2 is on the right. And by looking at the equation here, I can see that it's a smiley parabola. And if I take that shape through the critical points, it will help me to justify where this equation or where this expression would be bigger or equal to 0. And as I said before, everything above the number line is bigger than 0 or positive. Below the number line is smaller than 0 or negative. And on the number line is equal to 0. And we're looking for values that are bigger or equal to 0. So that includes the critical point and everything above the number line. So from negative 1, I can see that I'm moving left. So x must be smaller or equal to negative 1. And from 2, I can see that I'm moving towards my right. So x must be bigger or equal to positive 2. Now, next example, we want to list all the integers that are solutions to x squared minus 16. So we start with the inequality again, x squared minus 16 smaller than 0. And I can see that this is a difference between two squares, so it become x minus 4 and x plus 4 smaller than 0. And I can see my critical points would be x equals to negative 4 and x equals to positive 4. Now I represent those on the number line. So it'll be negative 4 and positive 4. And I can see that the shape of the parabola is a smiley shape. So I draw the shape through the critical points. And now in this example, we have smaller than 0. So you could see that the graph is smaller than 0 between negative 4 and positive 4. So if this was a simple inequality, it will be x must be smaller than 4, but x must be bigger than negative 4. But it says list all the integers that are solutions to this inequality. That means all the positive and negative whole numbers between negative 4 and positive 4. So therefore, x is equal to, and when we make a list in mathematics, we do curly brackets. And we start from negative 3, negative 2, negative 1, 0, 1, 2, and 3. Notice that we do not include negative 4 and positive 4 because it said smaller than, not smaller and equal to. And those are our values then. In our next example, we have 6x squared minus 3x over 3 smaller or equal to 3x squared. Now the temptation is to multiply out with the 3 in the denominator on the right hand side, but you can also see that 6 and 3 are multiples of 3. So it will be 6 divided by 3, which is 2x squared, minus 3 divided by 3, which is negative 1x, which is smaller or equal to 3x squared. Now, What I can do is I can rewrite it in standard form. So it will be negative x squared minus x. Now some people do struggle to work with a negative x squared. So what you can do is you multiply everywhere by -1. That'll become x squared plus x. But remember, when you multiply or divide by a negative, the direction of the inequality would change. Now it's a simple solution. All that I need to do is factorize. And I can find my critical points, which is x equals to 0 and x equals to -1. Then I represent these on a number line. Remember, the smaller values on the left, the larger value on the right. And because I changed x to a positive value, I know the shape of the graph. And as explained before, we can see that the positive values are above the number line, which acts as our x-axis. So for this inequality to be true, x needs to be smaller or equal to -1, meaning towards the left of -1, or x needs to be bigger or equal to 0.